In this video, I'm going to go over the practice problems for week 3 in the video notes and practice quadratics in the real world. So I'm going to go ahead and pull up my screen here. Just give me one moment. All right, so here in these practice problems, we're given the scenario. On some other planet, Thor stands on a bridge and throws his hammer at his brother Loki, who is at ground level. In this equation that they give us, h, or h with the t in parentheses, means the height. So this is going to be our height. And the height is going to be modeled by this equation, that -2 times t squared plus 60 times t plus 3,600. And here t represents the number of seconds after Thor throws the hammer, and h is the height in meters. All right, so here question number 1 is asking us, what is the height of the hammer? So we're solving for this part of the equation at the time it is thrown. So this is immediately when Thor lets go of the hammer. And we also call this the initial time. And if you think all the way back to like our very first month of algebra, we call that time of 0. So when time is 0. I'm sorry, that should be an equal sign here. So we're going to go ahead and plug in 0 into this equation and see what height we get out. So we're going to get h equals -2. Now instead of t squared, we're going to have 0 squared. And then plus 60 times 0. And then plus 3,600. So at this point, you could go ahead and type this part into the calculator, and it would give you the final answer. Now, if you want to solve this by mental math, we just need to remember that when we multiply anything by 0, that answer is 0. So here, 0 squared is 0 times 0, which is 0. Times -2 is also 0, so we can just get rid of that. Here, 60 times 0 is 0, so we can get rid of that. And we're left with this 3,600. So at time 0, right when Thor throws the hammer, our height is 3,600 meters. All right, here in question number 2, it asks, when will it hit the ground? So this question is asking something that's really similar to what we've been doing for the last 3 weeks, which is solving quadratic equations. So here, when we solve a quadratic equation, we're looking for the x-intercepts or when y equals 0. Now, if I graphed this equation, and you could do that on Desmos real quick, it will show you what that x-coordinate is. So graphing this is definitely one way you could solve it, and I will show you how to do that in just a moment. Another way that you could solve this is by using that quadratic formula that we learned last week. And that's really good when we don't have a graphing tool. So here, when we do the quadratic formula, it's -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Our a, b, and c numbers are coming from this equation where our a is -2, our b is 60, and our c is 3,600. So we would have -60 plus or minus the square root of 60 squared, and I know I'm running out of room here, minus 4 times -2. And then here in that parentheses is going to be times 3,600 all over 2 times -2. All right, then we're doing calculator steps. We still have that -60 plus or minus. Under that square root, 60 squared is 3,600. And then -4 times -2 is +8. And I'm going to go ahead and plug that one into the calculator. +8 times 3,600 is 28,800 all over -4. And then we just keep going. -60 plus or minus. I'm going to go ahead and simplify this part. So that 28,800 plus 3,600. I do that in the calculator and it gives me 32,400. I take the square root and that gives me 180. From this step, you would break it up into a plus equation and a minus equation. So for the first one, we would get -60 plus 180, which would be 120, divided by -4, and that would give us -30. For the second one, we would use the minus sign, and I'm actually gonna do that in a different color here. So we would do -60 minus 180, which would be -240, divided by -4, which would be +60. Now here, because we're talking about time, we want to know when it hits the ground. Time can be negative, so the negative answer is not the one we're looking for. So we know the positive answer here has to be right. So the hammer will hit the ground at x equals 60 seconds. And really that should be a t, because we're talking about t for time, but I know we're used to using x. Now that was a lot of math, so really quickly, I'm going to show you how to graph this on Desmos to solve it, which will be a much quicker way of doing it. And then I'm going to make a second video for part 2 and part 3 here because we're running out of room. So if I pull up Desmos, and actually you can do this from Canvas. I want to show you how to do that. So I'm going to pull up Canvas here. And I'm going to pull up our course page, Algebra 1B, and our announcements, and the calculator resources. So here, I want the graphing calculator, so I'm going to click on that one. And I'm just going to type in this equation that they give us, that -2. Now, you could use t squared. X is also fine. As long as you have the squared part, you can use whatever variable you want. So I'm going to do -2. I just need to see if there is a different negative sign here. No, I guess we'll use the minus sign and hope that works. All right, -2. And then they have x, so we'll use x, so x squared. And then we have plus 60t, but we're going to use x. And then plus 3,600. Now, we can't see that graph yet, but if we zoom out really far, we'll be able to see it. So this is the peak, and actually this graph is really going to help us solve the rest of these problems, so we'll probably go ahead and use the graph for the rest of them. So right now we want to know what that x-intercept is, so all I have to do is click on it. We can see this one at -30, that one at +60. Again, the +60 is the one we want. Time can't be negative. This way was a lot quicker than doing all that math. So definitely use Desmos if you can. It is a resource. You can solve by graphing. Don't feel like you're not doing enough math or you're getting around the problem by doing it this way. This way is actually the fastest way to do it. So I'm going to go ahead here and I'm going to pull up that next problem and we're going to actually just see if we can solve it on Desmos. I'm going to erase some of this since we're really running out of room here. I'm just going to go ahead and type that answer back in. We said t here, or x, whichever, it's fine. T is 60 seconds. Yes, you should use units. Labels are very important. All right, we want to know the maximum height of the hammer. This is the same thing as the maximum of the parabola. And remember that parabola is just what we call the shape of the quadratic function. So our graph looks something like this. And we want to know what's that very top point. Remember, the x is going to be the number of seconds, and the y coordinate is going to be the height, and that's what we care about, is that y coordinate. So we're going to figure out what that is. I'm going to pull the Desmos graph back up, and I just scroll up till I get to the very top right here. I click it, And that tells me that the maximum height is 4,050 meters. 4,050 meters equals our height. That problem took 15 seconds to solve with a graph. I like that. And we want to know how many seconds will have passed when it reaches that height? Well, that would just be the x coordinate. So at 4,050 feet, the hammer was thrown 15 seconds ago. So our x coordinate here is going to be that 15, so 15 seconds. And this is how you solve these 4 problems. Now, they could be solved by the graph. You could use the quadratic formula. You could use factoring, all of those methods that we've learned to solve so far that we're reviewing this week. It's really whichever you're most comfortable with and what makes sense for that problem. Here we have really big numbers and we have negatives. So Desmos and graphing is a great way to solve this. If you're still having problems with these, please come to the Zoom sessions today or Thursday or Friday, and we can go over some of these and some other problems.